Good morning. Get out your Chapter 6 notes. Turn to Lesson 6.5, Applying Systems. Okay, we have seen this before earlier in the notes, choosing the best method. So we're going to actually use this today, and we're not going to solve these problems. Instead, we're just going to determine the best method to solve them. So which would you use, and why is it the best? Okay, so let's look at the problems, and then I can show you the justification of why it makes sense that I would choose it. So first problem is both of these are in standard form. So if they're both in standard form, I would not choose graphing or substitution. Okay, they work if you have a y equals. Okay, these two work if you have an ax plus by equals c. Both of them do. Okay, and those are already opposites. Those are going to cancel. So all I would have to do is add. So elimination by adding is the best option for this one. So circle that, put that plus there so you know why we chose it. And then your answer is elimination by adding. Put a little plus sign. Okay. Number 2, I have an x equals, and then I have one in standard form. So we know automatically I'm not doing these bottom two because they're not both in standard form. And if I have an x equals, we're going to do substitution. X equals. It's the only time that if you have an x equals, because you wouldn't, if you have a y equals, you wouldn't want to graph. Or if you have an x equals, you wouldn't want to graph. Only x equals would you do substitution. So circle this x equals, because what you would do is you would take this and put it in place of that x. We're not going to solve it, but that's what you do. So the answer is substitution. Okay, next one. They are both in standard form, so I'm going to use one of these two. Okay, will they cancel originally the way they're written? They would not. But if I multiplied that first equation by a -2, then those would cancel. Okay, so put your little -2 there, circle these, because that's what would cancel, and we're going to do elimination by multiplication. With an x for multiplication. Now, I didn't have an example like this, but if I had two equations that were like this, that would be graphing, because they're both y equals. Okay? Okay, flip the page. We are going to write out the equations, but we are not solving them. Okay, so we're just practicing here. So we have two variables, x and a y. We need to define what they are for each problem. So let's read the scenario and then figure it out. It says the cost of 5 squash and 2 zucchini is $1.32. 3 squash and 1 zucchini cost 75 cents. Find the cost of each variable. That's what we're trying to figure out. So let's do x is the cost of squash, and we'll do y is the cost of zucchini. Now, you want to write two equations. Basically, this sentence is one equation, this one is another one. So 5 squash, we don't know what they cost, but that's x. And represents plus 2 zucchini, so 2y equals 132. There's the first equation. The second one, 3 squash, so that's 3x, and 1 zucchini, 1y, or just y, equals 75 cents. There's your two equations. You would solve them by elimination. Okay, next one. Again, we want to define what x equals and y equals. Talent show committee sold a total of 530 tickets in advance. Student tickets cost $3 each. Adults are $4 each. If the total receipts is 1,740, how many of each type of tickets were sold? So we're going to do x is the number of student tickets sold. And then y will be adults. Number of adult tickets sold. So here's what I do on a problem like this. If you have a number and then you have $3 amounts, the $3 amounts go in one equation together, and this other one makes a simple equation. So the simple equation is that it's how many tickets were all together sold. Well, we don't know how many you bought of each, but it's these two. So it's just X plus Y equals 530. Because number of adult or student tickets, let's say that was 10, Y tickets, let's say it was 20, and equals your total, which obviously doesn't equal 530, but something like that. Then all the dollar amounts go in the other equation. So students is $3 times how many tickets we sold, plus $4 times how many adult tickets sold, and your total cost, $17.40. There's your two equations. That's a pretty common scenario that you're going to see. Dollar amounts and then two added together equals the total of how many something sold. Okay, last problem. Oh, and how would you solve this? Probably elimination as well. You'd have to multiply by a 3 or a 4. Okay, next one. X equals Y equals. Rob has 40 coins. They're all dimes and quarters, worth $7.60. How many dimes and how many quarters does he have? So let's do X is number of dimes, and we'll do Y as number of quarters. Okay, same scenario. You're going to do dollar amounts in one equation, total in the other. Well, the total is this 40 coins. So that's going to be X plus Y equals 40. Now, the dollar amounts is this one. We know the dollar amounts of quarters and dimes. We don't have to, they didn't have to give that to us. So a dime is 10 cents. So you're going to represent that as 0.10 times X, plus a quarter is 25 cents, 0.25 times Y, and my total is $7.60. So those are all dollars, those are all totals. That's it, guys. And again, I'd solve this one by elimination as well. Okay, check Google Classroom for your assignment.